Good morning, everyone. This is Lori DeToro from eMaint and Fluke. Thanks so much for joining us for this month's Best Practices webinar. As software and sensor providers, we offer an array of webinars and other education, including product demos and product training. Our Best Practices webinar series focuses not on our technology and software, but on maintenance strategies and solutions with speakers from a variety of backgrounds to share their knowledge. We are very pleased to have with us today James Kovacevic from Eruditio, who will be presenting today's topic, the IoT of maintenance, what's important and what's not. Good morning, James.
Good morning. Thank you for the opportunity to talk about the IoT of maintenance, what's important and what's not.
Well, thank you so much for joining us today. While listeners are logging in, I want to ask you a question. I was happy to meet you at SMRP and again at our own Accelerate conference in November. Are there any other conferences or trade shows that you recommend for MRO professionals?
Well, there's a few. Not sure how many Canadians you have in the audience, but if you do have some Canadians, Maintrain is a great option up here in Canada. Down in the US, Reliable Plant as well. I will be presenting a paper at Reliable Plant, I believe it's in April, on job planning and procedure-based maintenance. So those are two great ones as well. There are a lot of others depending upon what you're specifically looking for. If you're talking about SAP or Maximo, there's specific conferences for them. There's Reliability or IMC or Reliability 2.0 as well. There's a variety of different ones. All have great topics, great speakers. What I find though is looking ahead a little bit more and picking the one that has the most topics related to what you're trying to overcome is probably the best way to pick the one for your organization and for yourself.
That's great information. Thanks so much for letting us know about that. But before we get started today, I want to take a few minutes to go over some housekeeping items. The session is being recorded, so the phone lines will be muted to minimize background noise, and we will save time after the presentation for attendee questions. You can use the question feature on GoToWebinar to submit your questions or comments at any time during James's presentation, and I will read them to him so he can respond during our Q&A period at the end. If you'd like to receive a copy of today's presentation, please let us know during the survey that will appear in your inbox after today's session. The recorded webinar will also be available in eMaint University and on the eMaint website Best Practices page. So I think that's all of our housekeeping. So James, please let us know a little bit more about yourself, and we look forward to the presentation.
Excellent, thank you. So hello everyone, my name is James Kovacevic. I've been involved in maintenance, reliability, and asset management for over 15 years. I'm currently a principal instructor at Eruditio. Eruditio is an education firm based in Charleston, South Carolina. We offer the Inspired Blended Learning Curriculum for plan scheduling, reliability engineers, maintenance managers, and in asset management. What separates their curriculum from the others is there's a combination of in-class, e-learning, and you're provided with coaching during the application of those techniques over the course of a project that you will be focused on during that curriculum. I'm also the host of the Rooted in Reliability podcast. For those of you that have not had a chance to listen to it, I suggest you check out either iTunes, Stitcher, or reliability.fm, and you can find all the episodes there. Every week we interview another leader in maintenance, reliability, and asset management to discuss various topics: plan scheduling, spares management, reliability engineering, training, change management, all the topics that apply to everything we do. All right, enough with the commercialism. Let's jump into it. So before we start, I want to get an understanding of who's on the webinar so I can cater the information a bit differently for everyone. So if you can go ahead, Lori, and start the poll question. Just want to get an understanding of your role in your organization so I can cater this appropriately.
Sure, I'm going to launch that now. And please let us know what your position is in your facility. And we'll try to wait as long as we can to let as many people as possible answer the question. If it were a little more complicated, I'd read it, but I think you all can handle it yourselves. All right, we've got about 75% have answered, so we're going to go ahead and close it and get our results. And so 34% of the folks on the webinar are maintenance managers, 27% engineers, 7% planners and schedulers, 16% operations, and 16% management and IT. So it looks like you've got maintenance managers and engineers are our main participants.
Excellent.
So,
but it's a good, well-rounded group, having operations, maintenance, IT, or management, and IT in there as well, because this is something that impacts everyone. IoT. So, what are we going to talk about today? Well, we want to first begin by understanding what is IoT. Then we want to understand what are the benefits of implementing IoT. What can organizations that leverage IoT expect from it? Then within IoT, there's multiple components we want to talk about, such as big data, machine learning, and the different types of machine learning, because all of these play together to actually give us the results. One of the things, too, I want to talk about is the factors to consider before implementing IoT. One of the things that I commonly see is organizations jump into IoT without understanding all the different aspects to it, some of the business processes they should have in place before they implement it, and so on and so forth. So we're going to talk about things you need to consider before jumping in to IoT. Then finally, once we have those foundations or factors in place, then we're going to talk briefly about the steps to implement IoT for your organization. This webinar is fairly high level, and I highly recommend anyone interested in learning more about IoT to spend some time learning about all the different aspects of it through conferences, LinkedIn Learning, Coursera, etc., before implementing IoT. You want to make sure you have a good, solid understanding of all the different pieces that come together before diving into it. Now, one more poll question before we get started and diving deep into it is I want to understand the knowledge level around IoT with our audience. So, Lori, if you can go ahead and kick off the next poll.
Happy to do that. All right, here we go. What is your IoT knowledge level? Are you an expert? Do you know the basics? Have you heard of it, or have you not heard of it? And we have got a good amount of folks have already answered the question, so we'll give it another few seconds. All right. The knowledge level is 5% are experts, so congratulations to everyone who is an expert. 36% know the basics, 35% have heard of it, and 24% have not heard of it. So you definitely have a lot of people who are going to be anxious to hear more that you have to share with them, Jane. So there we go.
So for everyone except the top 5%, and maybe even in the top 5%, maybe this will give you some ideas of what IoT is, all the different components, the considerations leading up to it, and so on and so forth. As Lori mentioned, if you have any questions, feel free to type them in the question box, and we'll be sure to answer them as we progress or at the end of the webinar. Now, what is IoT? Well, essentially, IoT, or Internet of Things, is connected devices, and they're connected to each other or to the internet, which enables these sensors to collect and exchange data within each other. You know, the connected devices could be current meters, voltage meters, temperature meters, vibration sensors, or a whole host of other devices. All these devices feed a tremendous amount of data to each other or into the cloud. These devices could be connected via cellular networks, Wi-Fi networks, or hardwired to a server. These sensors are being added to machines by original equipment manufacturers or organizations operating the assets to gain better insight to the operating condition of those assets. It allows them to identify potential design defects, identify how effective the maintenance practices are, and the current operating condition of that asset. All this data is being collected and analyzed to essentially enable the business to better detect potential failures, identify conditions leading to potential failures in similar assets, and decide on the best course of actions to prevent those potential failures from occurring, or to make a design change to prevent that from any potential failures from occurring again in the future. Depending upon the maturity of your machine learning and AI platform that you're using, you may be actually able to recommend actions to take moving into prescriptive maintenance when you fully leverage the platform. However, with adding all these sensors, the ability to collect data grows exponentially, which on one hand is beneficial, allows us to make better decisions. But on the other hand, if it's not managed correctly, the data can cost the organization time, money, and possibly cause poor decision making. That's why it's so important to understand IoT, the different components of it, some of the factors, and how to use it correctly. But back to IoT, essentially IoT is a bunch of connected devices with lots of data being collected and made available. Now, what are the benefits to IoT? With all this asset condition data available, there's numerous benefits to IoT. This list is not exhaustive, and there are many other benefits, but these are what I felt applied most to the maintenance and reliability professionals. We all know that collecting asset data, such as vibration readings, process parameters, can be time and labor intensive. Since most of these activities are manual, there's also concern around the quality of the data being collected, the accuracy and timeliness of that data. By using IoT and the connected sensors, this data can be collected very cheaply, sampled at whichever rate we want, and the data is consistent and repeatable because it's a fixed mounted sensor. With this type of data, analysts can trust what they're seeing and allows them to start making good recommendations and decisions quickly. Now, once we collect this data, we start combining it with some other technologies such as big data and machine learning. The machine can be used and leveraged to provide insights to our assets condition, may provide recommendations for maintenance actions, and enable the monitoring of other assets for potentially the same type of issue. This is a transition from our current predictive maintenance programs to a prescriptive maintenance programs, only doing the right maintenance at the right time. Now, with these insights to asset condition, personnel can take both corrective and preventative actions to reduce unplanned downtime and potentially planned downtime as well. Machine learning algorithms can provide recommendations for maintenance actions, but the key here is personnel must be able to act on those to deliver value to the business. One of my key factors to considering before leveraging IoT is that the business processes be in place to enable personnel to act on those. And we'll touch a lot more on that when we get to the factors to consider. There's also a knowledge gap that is occurring when our experienced staff leave the business and take their 30 plus years of experience with them. Most organizations don't have a plan to address this gap, but IoT can help. How? Well, as a machine learning algorithm begins to recognize signals from the machine condition data, it can identify looming potential failures, and more advanced models can actually recommend the task required to correct the issue. Having the machine learning model recognize the signs and make recommendations allows that knowledge to grow within the organization and not leave with the experienced staff. Now, all the above benefits come together to create a sustainable improvement in maintenance delivery, sustainable reduction in maintenance costs, while driving operational efficiencies. But these savings don't come right away. They come as the process is sustained and recommendations acted upon. That's why it's key to have a true understanding of what is IoT, what you want to do for your organization. Is you have to have an understanding of what is your goal and then act on the outcomes of the IoT platform. But as mentioned previously, there are many components to understanding IoT. Often IoT is used to describe the culmination of many different technologies such as big data, which describes the storage of all the data we're collecting with these sensors. May also cover machine learning, which describes the analysis of the data using various learning models and artificial intelligence. And then there's predictive or prescriptive analytics. And that encompasses a variety of statistical techniques from predictive modeling, machine learning, data mining that analyze the current and historical data we collected to make predictions about the future or otherwise unknown events. Business staff need to understand these technologies before they can fully implement IoT. IoT is just the connected devices and lots of data. It does not include the storage of data nor the analytics using the data to drive business decisions. Now, before organizations dive into IoT or Internet of Things, they need to understand the technologies, the organization, or they risk diving into IoT and not realizing any benefits. So organizations need to prepare for IoT to be successful. Preparation can include education around Internet of Things, machine learning, big data. There's also some preparation around understanding failure modes, failure mechanisms, and how IoT will help us manage those and the potential failures with them. Understanding the end goal of IoT is also critical. We need to, like any good project, we need to understand what that future end state is and have a plan to get there. And then lastly, robust business processes need to be in place so we can actually act on the recommendations coming from the machine learning and IoT platform. So we've mentioned big data a few times, but what is big data? Big data is essentially the large volume of data that is being collected and stored by those connected devices. And this data may be structured, and structured data has a defined data model that organizes the elements of data and standardizes how they relate to one another and to the properties of the real world. For instance, a data model may specify that the data element representing a car can be composed of a number of other elements, which in turn represents that color of the car and size of the car and defines its owner. Structured data related to maintenance may follow the ISO 14224 model as a guide for asset data, failure data, and maintenance data. Unstructured data is data that does not have that predefined model or is not organized in a predefined manner. Unstructured information is usually very text heavy, but it may contain data such as dates, numbers, and facts. This results in irregularities and ambiguities, which makes it difficult to understand using traditional programs as compared to the stored data that we talked about, the structured data. Big data may also be data collected from many other sources other than just the Internet of Things. It may come from supervisory control and acquisition systems, SCADA systems, if you will, manufacturing execution systems, ERP systems, CMMS systems. All those can contribute to big data. Now, big data is typically defined by the 3 V's. First being volume. Volumes of big data are huge and constantly growing. These volumes are expressed in terabytes or even petabytes. It's possible to collect as much as 15 gigabytes of data from a single asset in a single month using 2 to 4 vibration sensors. Consider that across all the assets in your facility, and you understand why they call it big data. Variety is another V of big data, and it can be found in varied formats. So what is common between a video, a song, a message on Twitter, a photo posted online, a post on a Facebook page, or a measure of an electrical meter, for example? Big data has a wide range of variety of data points, images, different sensors, work order data, all those things are varied. Then we have velocity. And velocity is the dimension in which the speed at which the data must be collected, analyzed, and used. More often, this data is being processed in real time using various technologies such as AI and machine learning. So the data collected from IoT is fed into the cloud and becomes big data. Now that we have that data, we need to be able to act on it. And this is where machine learning comes in. Machine learning is where the computer itself learns rules to solve a problem without being explicitly programmed. Machine learning takes all the big data and using various learning models, such as linear tree-based and neural networks, to solve problems. And we'll review each one of those briefly coming up. The output of from the machine learning model will be insights to what equipment is potentially failing, what similar equipment might have the same issue, when will a potential failure become a functional failure, and potentially what can be done to mitigate that potential failure. Now, machine learning is easier explained with an example. So we'll use one that most of you are probably familiar with, email and junk mail. Imagine you're writing a program to filter out junk email from your inbox using traditional programming. First, you'd have to write a complicated program that has all these different rules to decide if an email is junk or not. You might be looking for certain keywords, certain senders, and so on and so forth. Next, you try out the program by feeding in some test emails. Finally, you check the results to see if it's correct, if it's correctly separated the good emails from the junk emails. In this process, the hardest part is figuring out which rules help identify if an email is junk or not. It takes a lot of trial and error to come up with the right rules and accurately identify junk email without any false positives. Or worse, when spammers change their tactics and start sending junk mails differently, you have to go in and change all your rules. That's not machine learning. That's programming. Now, what machine learning does is we have a program that comes up with its own logic for filtering emails. That's what we do with machine learning. So here's how machine learning solution will work. First, we gather thousands of emails and sort them into two groups. One of the groups is emails we know are real, and the other group we know are spam emails. Next, we feed all these emails into a machine learning algorithm. The machine learning algorithm is an off-the-shelf system. We don't have to write any custom code to make it work. The machine learning algorithm will look at the two groups of emails and create its own rules for how to tell them apart. We are giving the machine learning algorithm input data that the original emails, the expected output, and whether each email should be classified as real or spam, and it creates its own rules for how to recreate the output from the data. The more data it sees during this training phase, the better chance it has of learning how to do it accurately. Once the model is trained, we can now use it to sort emails that it has never seen before. When we show it an unknown email, it'll apply the rules it learned during that training phase to correctly classify it as spam or real. With machine learning, we don't have to do the hard part ourselves. We don't have to write any email filtering rules or anything like that. The computer comes up with these on its own based on the training data it saw. The really cool part about machine learning is that the same algorithm we use to classify emails can be used to solve a lot of other problems just by changing the data we feed into it. So we don't have to change a single line of code. Now, we mentioned learning models, so I want to touch on these briefly. There's three main types. First one is linear learning models, and they're based more on statistics. And while we're not going to dive deep into statistics, we want to make sure we address them. So there's two main types. You have linear regression and logistics regression. And essentially, linear regression is the best fit line through all the data points, and predictions are numerical. The advantages, it's easy to understand. You clearly see what the biggest drivers of the model are. Some of the disadvantages to that, sometimes it's too simple to capture the complex relationship between the variables, and there's a tendency for the model to overfit. Now, logistics regression is an adaptation of linear regression to classify the problems, and this is using a yes, no, a 0, 1, that sort of approach. It's also easy to understand, but once again, same disadvantages as linear regression. Tree-based models are a bit more advanced. Now, decision trees are a popular method that work well with both categorical and real value data. They also form building blocks of more complex model methods. Decision trees operate on a rule-based method rather than attempting to discover a probability density function. The decision tree split the data up into nodes and determine an optimal set of rules that are required to classify the data. Now, typically, there's three types of tree-based learning models. First is a decision tree. It's easy to understand and implement. However, it's not often used for its own prediction because it often has too simple and not powerful enough models for complex data. Now, the random forest approach takes the average of many decision trees, which has been made by a sample of data. Each tree is weaker than the full decision tree, but combined they get a better overall performance. It's sort of a wisdom of the crowd, if you will. It tends to result in very high quality models. It's fast to train. Now, however, it can be slow to output predictions relative to other algorithms, and it's not easy to understand the predictions at times. And then lastly, there's gradient boosting, and that uses even weaker decision trees that are increasingly focused on hard data. It's very high performing, but a small change in the feature set or training can create radical changes in the model. And once again, it's not easy to understand predictions. And then lastly, we have the neural network learning model. And these are essentially, this is one of the more interesting models or algorithms out there in machine learning. Now, the name may suggest that we're trying to build a brain based on neural But what we're really trying to do is develop algorithms that follow the brain's lead. In particular, artificial neural networks are inspired by biological neural networks, and they have the data neurons, or really algorithmic neurons, that exchange information between each other with connections that adapt or weights that change according to experience. Some common uses of the situations is where rule-based learning does not work. It doesn't follow through, or you can't describe it well. This may be using images, trying to recognize photos, speech recognition. At any time we're trying to infer a non-linear function that's difficult to describe. What we have here is sort of a black box model where you have inputs, it goes into the black box, there's some sort of hidden processing there, and then there's the output. Great things about this, it can handle extremely complex tasks. No other algorithm comes close in image recognition, speech recognition, that sort of thing. It can be very slow to train, and it's almost impossible to understand the predictions that come out of it. Now, Lori, I'm going to queue you up for another poll question. Now that we have an understanding of IoT, big data, and machine learning, I want to get an understanding of who's actually leveraging and taking advantage of IoT.
Sure, I will start that poll right now. Are you taking advantage of IoT? Are you using it, implementing it, investigating using it, or you don't have plans to use it? And I want to give you all time to answer, so we'll wait a few more seconds, and we will, so far it looks interesting. Investigating is way up there in the responses, and I'm going to close it out now. And the results are 9% are using IoT, 9% are implementing it, 72% are investigating its use, and 10% do not currently have plans to use it. So the majority of people are interested, obviously, but not using it so far.
Yeah, that's interesting. For the 9% that's using it, 9% implementing IoT, be interested to get their feedback on, did they consider some of the factors that are coming up? Did they look at the different learning models? Are they understanding that, or are they using a purchase solution from a third-party company that covers all that and they don't have to worry about it? So you can comment on that in the chat box or send it to Lori via questions. That would be great. Now, for the majority that are investigating IoT, I'll give you some factors to consider before you implement it that will really make sure you drive the results you're expecting from it. Before collecting any of the data using IoT, it's important to understand why we're collecting it and what we're going to be doing with it. There is no point in connecting data that we will not use or contribute to the end goal. Just because we can collect it doesn't mean it's helpful. Now, one of the key things with data is any collected data needs a governance process to ensure it is accurate, consistent, and not skewed in different ways. Governance is essentially defined as the establishment of policies and a continuous monitoring process to ensure those policies are implemented. Essentially, a governance process controls who has access to edit data, view data, compliance to the data standards, and what actions must be taken if the data is not in compliance. Why is this so important? Well, let's consider material master data or spare parts master data for a second. Many organizations have gone through and cleaned up or done a cleansing of their spare parts data, standardizing descriptions, manufacturers, part numbers, so on and so forth. Well, if you don't have a data governance in place, which defines who can actually edit that master data, who can create new material sets, and so on and so forth, that material master data will become dirty over time because we don't have a governance process in place. Likely, in a few years, we'll have to go back and re-cleanse that data because now it's in a state of disarray again. Data governance ensures that once we clean data, it stays clean and is in good condition so we can actually use it effectively. Now, this goes back to talking about the structured data we mentioned previously. What data points are related, how will they be used, etc. This all needs to be considered ahead of time before starting to collect data and just put sensors everywhere. Speaking of structured data, ISO 14224 does a great job at identifying asset data, failure data, and maintenance data. If you haven't looked at ISO 14224 before, it serves as a great data standard for asset hierarchies, boundaries, and the different failure data and maintenance data. It also explains how to use that data to conduct various maintenance and reliability analysis, which, if you're going to be using IoT to collect data, might be a good thing to understand what some of the best practices are in using that data. ISO 14224 also serves as a great standard for setting up your CMMS hierarchy, so you can actually link the different failure modes and different assets to the right sensors in the field, and making sure they roll up or roll down depending upon your needs. Understanding failure modes is absolutely critical before implementing IoT. Now, a failure mode is essentially an object or component, the damage observed, and the cause. For example, bearing overheated due to lack of lubrication would be a failure mode, or bearing overheated due to overload may be another failure mode. While related, they're different. Once we understand the component, the damage, the cause, we can begin to identify what data we should be collecting to identify those potential failure modes. For bearing condition, we might consider acoustics, vibrations, various process parameters, temperature, load, so on and so forth. We need to identify what those specific failure modes are so we can link our data capturing strategy to those failure modes. Now, this type of relationship needs to be considered for each failure mode identified in an FMEA, or failure mode effect analysis, or RCM, or reliability center maintenance analysis. If you don't have any failure mode effect analysis or RCM analysis, then you truly need to consider what data to collect, as the foundations of a good reliability program aren't in place yet. Make sure you have an understanding of those failure modes so you can link that to your data capture strategy, your IoT strategy. If not, you may be collecting data that will not be used. Some vendors now may be able to provide this information based on their past experience, but as a business, you really need to have an understanding of your failure modes and your data collection strategy to ensure the solution being provided by the vendor is aligned with your objectives. This once again goes back to collecting data for no reason. If the data is being collected cannot be correlated or related to a specific failure mode, is it worth collecting? Probably not. Collecting and storing data requires bandwidth, storage, server space, which all costs money. So don't waste resources collecting data you don't really need. Now, some other factors to consider before using IoT is having the right business processes in place. And these include work management, materials or MRO management, CMMS governance, data governance, root cause analysis, and PM optimization. Now, if you don't have these good business processes in place, you may not get the results from IoT that you expect. Let's start with work management or plan and scheduling. If you don't have this in place, how are you able to take the recommendations from the machine learning algorithms and act on them? Likely what will happen is you'll get the request or the notification that something's occurring and you should act on it, and it will go into the CMMS. Now, that request may be lost in the backlog of work. It may not be prioritized properly or scheduled, and the asset will fail with either the request or work order still in the system. We didn't act on it quickly. That's why we need to have plan and scheduling in place. Now let's consider the MRO or spare parts management process. The business gets a warning that a component is failing and we need a replacement part. Now, if we don't have a good MRO process in place, a few things could happen. One, either the CMS will say we have stock, but we actually don't. So when we go to execute that job, we don't have the parts to do it, and the asset fails. Or we order a part, the part's received, but it never makes it to the stock room or to a kitting shelf, and the repair is not performed as planned, and the asset fails. Once again, you need to have the basic business processes in place to make sure you get the results from IoT. Now, if the CMS was not set up correctly, will the work request be linked to the right asset? Will historical information be available so we can look and analyze and understand, is that truly the right recommendation, so on and so forth? This may sound trivial, but how many times have you heard your craftspeople go to a job and say the work order was assigned to the wrong job, or that fault isn't on that particular asset? It's very common, so make sure we have the CMS set up correctly. Data governance, we already discussed that, so we're not going to dive into that again. Now, root cause analysis. Well, IoT will provide insights to failures or potential failures, allowing us to plan that corrective action, but it will not enable us to eliminate that issue from reoccurring. This is where having a good root cause analysis program comes in. So when we focus on root cause analysis and defect elimination, i.e. removing that source of potential failure through redesign, new procedures, new materials, so on and so forth, we actually have the ability to drive down costs sustainably. A good root cause analysis program will have different triggers in place that define when we need to actually do a root cause analysis and to what level. Remember, IoT provides insights to pending failures. Root cause analysis eliminates them from occurring again. And then lastly, PM optimization. PM optimization is also critical as our IoT program gains credibility and our other processes enable us to act on those recommendations. We can begin to then scale back on our manual intensive PM program. This requires a careful analysis of the failure modes to ensure we do not remove any items from the PM program that are not being covered by our IoT strategy. Now we can leverage our staff for doing more root cause analysis, more redesign work, more proactive work, truly leveraging them to really drive down costs sustainably in our organization. Now, the last poll question before we move on, or if you can queue up the poll, is does your organization have those factors to consider in place? The business processes, data governance, understanding failure modes.
I'm going to launch that poll now. James just asked the question. So do you have all of the factors in place, most, a few, or none? And we're going to probably take about 10, 15 seconds to let as many people as possible answer, or those who want to answer. And then I will read the results to James. All right. Well, almost 70% have answered, so we're going to go ahead and close it. And 5% have all the factors in place, 21% have most of them, 52% have a few, and 21% have none. So about 73% either have a few or none in place.
Oh, interesting. For those implementing IoT or that have IoT implemented, I'd be interested if you could comment on if you don't have all those in place, are you actually getting all the benefits you expected from IoT? And if so, why do you think that is without having all those factors to consider in place? If you can go ahead and put that in the chat or question box, that'd be greatly appreciated. All right, so I highly encourage you, if you don't have these in place, make sure you get these in place before you go down the route of IoT. Many people think IoT is a silver bullet that will fix all the problems. If we don't have the basic business processes in place, understanding failure modes, IoT likely will not fix all of our problems and maintenance issues that we're having. All right, so now that we have all those factors in place, we understand what IoT is and what we want it to do. How do we actually implement IoT? Well, there's 10 steps that we're going to cover. The first one being is identify areas of vulnerability. What systems of major components are eating your lunch? Where can substantial financial gains be made through increased availability, throughput, so on and so forth. This is really identifying what assets are causing you the most problems and identifying those up front. This could, and I highly suggest it starts with a pilot area. 2, we want to conduct that RCM or failure mode effect analysis to determine what failure modes should be monitored and identifying what parameters we should be monitoring for each one of those failure modes to detect that potential failure. Then we want to audit the asset to determine what parameters are the onsets of the failures being monitored, like we just discussed. 4, we want to get smart on IoT, big data, machine learning, and understand what it truly can do and cannot do for your organization. It's not a silver bullet, but it is hugely powerful. So we want to make sure whoever's in charge of IoT, whether it's the project or ongoing, make sure they have a great understanding of it, all the different components and how they work together. Next, we need to make provisions for collecting and analyzing that data. Is it converting analog to digital sensors? Are we going to go wireless? Are we going to go wired? Are we going to go cellular? All these different things to get the data collected. We also need to decide at what point of analysis do we want to do it. Do we want to use edge computing, so we're doing the analysis very close to the sensors and then just pushing out the final results of that? Or are we going to collect it all in a big data cloud and do all the analysis centrally. Big decision points there definitely impacts the hardware you need to set up your IoT network. And number 6, we want to define at what level the analysis should occur. Are we doing it, like we discussed, at the edge, the plant, the cloud, or a combination thereof? There's benefits and pitfalls for each one of these, so we really need to understand what is going to be most effective for us. Then we need to assure permanent management support and funding for the initiative. This means doing a pilot area, getting stakeholder support aligned and established, making sure those stakeholders are involved and understand the benefits of IoT. Lastly, we want to acquire the assistance of organizations that can help. This may be helping with infrastructure, of planning, with minimal or no capital investment. Can assure prescriptive maintenance recommendations are based on a firm understanding of the assets, the failure modes, and advanced indicators of those potential failure. You really need to make sure you vet the organizations you're going to work with to help with IoT. Once we actually have the IoT in place now, we need to document the results using key performance indicators, making continuous improvements, and show the business case so we can get funding to expand from the pilot area to a larger area. Lastly, you need to keep your master plan current, updating it at least annually. This means understanding where we currently are with IoT, what improvements do we want to make in the future, getting that into the capital budget for funding, and so on and so forth. We need to make sure we have that plan, we're continuously looking ahead and keeping it current with technology. Now, some of the common pitfalls we see with IoT is first, that it's a silver bullet. This is similar to the thought process of we'll get a new CMMS and now we'll fix all of our problems. Definitely not the case. You need IoT as well as new CMMSs need to be well thought out, well supported, and well planned out to get the results that are expected. They need to be supported by business processes, performance management, and so on and so forth. We also understand failure modes, so I'm not going to spend a lot of time on it, but I want to make sure that when you do IoT, you do link it to failure modes. It's vitally important to do that to make IoT successful. Don't jump all in with IoT. Select a pilot area, implement it there, learn from it, revise your strategy, and move on. Start small and grow it, as there'll be lots of learning pains as the program matures. In addition, the cost to do a pilot is much less, which will allow you to gain some support from upper management and senior stakeholders and demonstrate the benefits before you spend that large amount of capital. Be selective of who you partner with in your journey. Get client testimonials to understand your partner's approach and their technology. Be very rigorous in selecting your partner as it will impact your entire program. Make sure you look past some of the fancy graphics and videos and so on and so forth, and ensure they actually have an understanding of maintenance, reliability, asset management best practices as well. There's lots of machine learning companies out there, but do they actually have an understanding of maintenance and reliability? As with all improvement projects, you want to make sure you get full executive support and have the right executive sponsor for these projects. Without that active support, the project will likely lose steam and end up as another project that failed to realize the benefits. Lastly, don't just implement IoT. Make sure you have an understanding of what IoT consists of, what the benefits will be for the business, how you'll measure progress, and how you know you'll be successful with it. Make sure you consider more than just one KPI or metric. Have a few balanced KPIs with your program to measure progress and the end goal. There's no point in starting IoT if you don't have an end goal or state identified. Now, IoT has a lot to offer, and it has the ability to provide significant competitive benefits to those businesses that take advantage of it. Those that master the technology early will leave others behind, but you have to implement IoT strategically, as we discussed throughout the webinar. The enhanced decision-making provided by IoT is where that competitive advantage will come from. This will lower the costs of maintenance, it will lower the life cycle costs, and it will also lower planned and unplanned downtime when combined with root cause analysis. Lastly, before you dive into IoT, I can't emphasize it enough. Start learning about IoT, big data, machine learning. You don't need to become an expert, but you need to be able to ask the right questions when having these conversations with potential partners. You can start by blogs, webinars such as this, conferences. LinkedIn Learning has a great number of courses on big data, machine learning, artificial intelligence, or other massive open online courses such as Coursera offers stuff on this very topic. By asking the right questions, you can ensure that your prospective partners understand your goals and they actually have the right solutions to enable you to achieve those. In closing, make sure you start learning about IoT, plan it out, and take advantage of it because it is coming and it will be a huge disruptor in the way maintenance and reliability is done. And with that, I will pause and open up for any questions that we may have.
James, thanks again. This was a great presentation, and we do have a few questions. I want to encourage everyone to continue sending your questions in. We have about 10-15 minutes to answer them. What we do not get to, James has agreed to answer, and we'll put it on the eMaint blog so that you can get the remainder of the answers if we don't get to everything today. So the first question we have is regarding IoT data. Someone has to determine what is significant. It doesn't just magically become significant. Data variation may be normal. How do we sort through all the data to make sense of it?
Great question. One, I'm going to go back to understanding your failure modes. If you have a good understanding of your failure modes, you should be able to identify what indicators are leading up to that particular failure mode. Bearings, for example, you may have vibration, temperature, maybe even current from the motor that's driving that power transmission line. Once you have an understanding of the failure mode, you can link it to all those. Now, if you're referring more to a lot of the process data you may be collecting through SCADA and so on and so forth, that's going to require a lot more. And that's where some of those more advanced learning models will come into place, like neural networks and some of the decision trees that we looked at. By providing all that data to the machine learning algorithm, it can sort through some of that and identify what is important and what is not. But if you're talking specifically about what sensors should we put in, that really goes back to linking to the failure modes.
Great, thanks. James, this one's a long question, so I'm going to read it. If you need me to reread any parts of it, let me know. One of the biggest challenges I see with IoT is applying appropriate analytics algorithms for a massive amount of sensors, even on one asset. Machine learning for predictive analytics as asset management is still relatively undocumented. Do you have any suggestions about where to find best practices to apply the best machine learning algorithms for failure analysis and recommendations for best resolving critical problems? That was a lot.
Yes, great question. It is still fairly new in asset management, I will agree. And there's a few companies that have kind of led the pack in applying this to asset management. The different learning models, it's difficult to pick. Now, there's a few organizations out there that have done some great stuff with this specifically, and they may be able to provide you with some of the right answers. GE Digital is doing a lot with IoT, prescriptive maintenance, analytics, that sort of thing related to asset management. Intel is another company that's done a lot with it. They're leveraging all that different data coming in using complex learning models specific to maintenance, reliability, and asset management to generate those results. IBM Watson has done a lot in that as well. So I can't say which one is the best, but I would say if you start talking to one of those three organizations, they might be able to help point you in the right direction.
Actually got a question about this, so I'm going to answer it briefly and we'll answer it further on the blog. One person asked, what does Fluke offer and what are its products? If you'll go to www.excelix.com, a lot of what James has mentioned here about some of Fluke's products and Fluke's IoT offerings are at that website, and I will leave that there and you can go and look for more information on that site. The next question we have is, where do we start learning the specializations needed for big data, machine learning, and IT communication?
Great question. So I started on LinkedIn Learning or lynda.com. They have a lot of great courses and learning paths on that specific topic. Some on artificial intelligence, some on IoT, big data, and so on and so forth. They have some great ones there. There's also some good ones on massive online open courses, such as Coursera. There's a few others which are offered virtually, but are actually courses that are taught in universities on the very topic. So those conferences, there's some blogs on the topic as well. I would start in one of those. I like LinkedIn Learning to start because you follow a learning path building on knowledge from previous modules and so on and so forth. So it's kind of guided. So you have the basics before you get into the advanced stuff.
All right. The next question is, how prevalent are neural networks in current IoT CMMS implementations?
I'm going to say they're not very prevalent. Aside from a few organizations and maybe a few companies that are applying it, it's not very prevalent. Now, I know IBM, they own Maximo. They use Watson in a lot of their asset analytics and prescriptive maintenance stuff. So it'd be prevalent there, but only if you subscribe into that particular feature, function, so on and so forth. So I wouldn't say they're very prevalent at this point. They're definitely what's needed with all the asset data that we can collect. But most organizations that I've had the opportunity to work with are not taking advantage of neural networks.
Great answer. The next question we have, where they keep coming in, is comparative analysis possible within the data collection system, the CMMS EAM, without human intervention?
Sorry, can you repeat that?
Sure, sorry. Is comparative analysis possible within the data collection system, within the CMMS or the EAM, without human intervention?
So it can be. If you're collecting very good data in your CMMS, such as process parameters, thinking of SAP if you're using measurement points or something like that, and you're collecting data, and you can stream those live into CMMSs as well. And I believe eMaint has the ability there as well. If the data is really good, the CMMS itself will not do the analysis or prescriptive analytics or for you. You need to export that to a model of some sort, a learning or machine learning platform, something of that nature. You definitely can use the data, and we talked about unstructured data previously with text, pictures, stuff like that. We can take that information from work orders and use that as well as part of our unstructured data analysis, but you really need to have a platform that's set up for that specifically.
Great, thanks so much. This is a question that I think a lot of people ask, and there may not be an easy answer to it, but I'm going to ask you to see what you think. And of course, it was one that came in from one of our attendees. As IoT grows, how do we protect our data and internal classified information and processes?
Good question. So obviously, cybersecurity is a big concern for many organizations. That's a whole nother topic, and I'm not even going to pretend to know what I'm talking about when it comes to cybersecurity. But there's definitely different aspects you can consider. So one of the things that I've seen organizations do is they have a completely separate network for IoT, all the connected devices, that sort of thing, which is separate from their company intranet, if you will. That's one approach. Aside from that, I can only recommend, getting the counsel of a expert in cybersecurity.
Great answer. Cybersecurity is a huge issue. This is an interesting question that I hadn't thought of. Are unions pushing back against Industry 4.0 implementation?
That is an interesting question, and I never thought of that. I have not heard of anything regarding it, but part of that also goes back to your change management practices. If you're implementing Industry 4.0, the unions might be concerned because of potential layoffs, downsizing of the organization, so on and so forth. But if you think back to what I mentioned previously about root cause analysis, now if the guys or craftspeople are doing less data collection, now we can leverage them more for some of their better skills. Now we can use them in root cause analysis, designing new processes or new features or changes to our equipment so we can truly eliminate the causes of those potential failures. I think if you present it that way and you're honest and in that message that we're not going to lay anyone off as a result of this, we're going to repurpose them for this and this to drive down costs, I think that would be acceptable, but I have not seen any pushback personally from unions regarding IoT and Industry 4.0.
Okay, we probably have time for one more question, maybe two, but definitely one. And I hope I am understanding this question correctly. I think they're asking, how do you justify starting a maintenance IoT versus logistics and supply chain IoT? Do you see a difference in the need for those? And is it different to set up one versus the other?
I guess it would depend on where are the constraints within your business. If you're constantly having issues being able to make a product and meet your service requirements for your customers, then definitely you can consider in maintenance. If we get good at it with maintenance, then we're driving down planned downtime, unplanned downtime. We're reducing the amount of working capital we need to tie up because we're not overproducing on weekends and so on and so forth like that. There's a lot of different ways. You need to build a business case around your particular application. If you need help with that, you can reach out to me and we can help you with understanding what is the losses within your organization and does it justify it. But you truly have to have an understanding of where are the constraints within your organization. Is it process efficiency? Is it machine availability? Is it unplanned downtime? You need to have a true understanding of all those things and the impact of working capital, inventory, so on and so forth within your particular organization. Sorry, it's kind of a long-winded answer, but there's a lot that goes into that consideration.
We do have time for one more question. How can small and medium-sized companies compete when the skill sets to implement these systems are so specialized and desired?
Great question. That's where you start leveraging the expertise of partners, such as Fluke and Accelix and others. That way you don't have to bring in someone full-time. You have a basic understanding of it. You tell them the goals, what you expect, and you work with them to do that. There's a few other organizations that work specifically with smaller organizations in implementing this in turnkey solutions. And they're actually not that expensive. They're more of I've seen a subscription model, so it's so much every month. There's no upfront capital investment. It's just so much every month. And that includes the sensors, the hardware, the analytics, all that stuff. So that might be a good way to go.
Okay, well, James, thank you again for a great presentation. We had a lively Q&A session there, and we greatly appreciate you taking the time to talk with our folks today. So thank you very much.
All right, thank you very much for the opportunity.
Absolutely, we'll definitely do this again. That concludes the day's presentation. Thank you, James, and our attendees for joining us. There will be a brief survey displayed at the conclusion of the webinar. We would appreciate it if you would take a few moments to complete the survey to ensure we are presenting content that you find relevant and helpful, and I hope everyone has a great day. Thank you.